Okay, welcome Algebra 1 Lab students to your video that will show you how to solve rational equations and to also solve work problems. Okay, so I'm going to get straight into it. As usual, you have a list of steps that you should follow to help you focus on the process for how to solve these problems. A couple of key things. We are now talking about rational equations, and so those are equations that contain ratios, i.e. fractions. And so you're going to need all of the skills that you've acquired so far in terms of your adding, subtracting, multiplying, and dividing of rational expressions to be used in this lesson. Okay, and then the next important key thing is to focus on the word solving. And so we're trying to solve an equation, we're trying to get answers or values for the variables. Final piece of the puzzle, we have this idea of something called an extraneous solution. This is just where the answer to the equation ends up being one of the excluded values, and hopefully you will remember excluded values are the values which cause the denominator of a rational expression to be 0, and you cannot divide by 0, so these are excluded values. Okay, so I'm going to get straight into it. There's the reminder of our golden rule, of course. We don't want to start by doing any cancelling when we are adding and subtracting, and this is basically our process. So go ahead and read through the steps if you need to. I'm going to refer to them as we go, but you can use them as a checklist. So we're going to start off. Step number 1 is to factor all denominators. So we're looking at number 1. All of our denominators are already factored, or rather they're monomials, and so there is no factoring. We need to determine the lowest common denominator. This is the same as the first step for adding and subtracting, only this time we are solving, but we still need the LCD. So in this case, what I'm looking at is I'm looking at an expression into which all three of those denominators will divide. In this case, our LCD is going to be 2x. Okay, and what I'm going to do is I'm going to take the LCD 2x and I'm going to multiply every single term in the equation by 2x. And we're allowed to do this because since it's an equation, whatever we do to one side, as long as we do it to the other side, the equation remains balanced. Since I'm multiplying in each of these cases, I'm going to end up with 2x over x equals 2x over 2 minus 2x over 2x. And I'm showing you a longer way of doing this. In future, I'd prefer that you just did the cancelling from the get-go. In this case, we can simplify each of these fractions individually to give us 2 equals x minus 1. Okay, so the purpose of finding the LCD and multiplying each term by the LCD is it led to an equation which had no more fractions, no more rational expressions. In this case, our equation is linear, and now it's relatively easy for us to solve using our reverse operations. X is equal to 3. Our final step would be to make sure that x equals 3 is not extraneous, namely, does that value cause any of the denominators to be 0? In this case, the answer is no. Okay, so I'm going to move straight on to example number 2. Same process. I have my denominators. I'm looking for the lowest common denominator, and in this case, 2p squared is the smallest number into which each of the three of our denominators can divide. I'm then going to take that LCD, 2p squared over 1, and I'm going to multiply each of the terms in the equation by the LCD. This time, however, I'm going to do some simplifying and cancelling from the get-go. So when I do 2p squared multiplied by the first rational equation, 2p squared will cancel with 2p squared, and I'll just be left with p squared minus 2p minus 24 minus, I'm going to change colors here so that it's fairly clear. When I do 2p squared multiplied by the term 1 over 2p, those will cancel, and I'll be left with So 2p squared divided by 2p will leave me with p multiplied by the 1 on top is where I get that from. And switch colors one more time. 2p squared multiplied by the term 1 over p. One of the p's will cancel and you will be left with 2p on the right hand side. So in each of those instances I've distributed and multiplied each of the terms. What I'm left with in this case is a quadratic equation because we have a p squared, and so to solve that I'm going to equate to 0 first. So p squared, I'm moving the 2p to the other side by subtracting 2p, and let's just move that a little bit down. So I'm going to have p squared minus 2p minus another 2p minus 1p, and we will get minus 5 minus 24 equals 0. We're now going to solve that by factoring. So we'll use our grid. 1 times minus 24, I need numbers that can multiply to give me minus 24 and add and subtract to give me minus 5. And so the factors in this case that we're after, 8 times 3 will give us 24, and add and subtract for the minus 5. Specifically, we need minus 8 and plus 3. So I'll write it in expanded form. P squared plus 3p minus 8p minus 24 equals 0. And then I'm going to factor by grouping. So I'm grouping each of those. Take out our common factor here, p plus 3. Take out minus 8, p plus 3. And my factored answer, is p plus 3 multiplied by p minus 8 equals 0. And therefore, final step in the equation is to write down our answers. So p plus 3 times p minus 8 equals 0. Therefore, p must be minus 3 or 8. Final step in the problem is to check for extraneous solutions. So I'm just going to have a quick look. Minus 3 and 8 will not cause any of our denominators to be 0. Okay, moving on. Now the problems get a little bit more difficult. They're more difficult because the identifying of our LCD, lowest common denominator, is more complex because of the denominators themselves being trinomials. Okay, so I'm going to cut a few corners here just in the interest of time. K squared plus k minus 30 is a trinomial. It's going to factor as follows. Factors of 30 that can add and subtract to give us 1k are going to be 6 and 5. I need it to be plus 6 and minus 5 is going to give me k squared plus 1k minus 30. You will notice that this denominator and this denominator are exactly the same. And so it's k minus 5, k plus 6 for both of them. In this case, the LCD happens to be the trinomial term, so k minus 5 times k plus 6, and I'm going to distribute that into my equation. So I'm going to multiply each of my 3 fractions by the lowest common denominator, and I will be left with, in this case, both of those will cancel, and you will be left with just 4. In the case of k minus 3 over k plus 6, the k plus 6 will cancel, and I will be left with k minus 3 multiplied by k minus 5. And finally, for our third term, we have both of those terms cancelling with the LCD, and I will just be left with plus 5. Again, this is going to end up being a quadratic, but has an added layer of difficulty because we first need to distribute that out and move everything to the right hand side. So I'm going to subtract 4 from both sides and distribute those. So k squared minus 5k minus 3k plus 15 plus 5 minus 4. And then I'm going to add and subtract my like terms. So I have minus 8k and then I have plus 16. I'm going to go ahead and factor those since we have a quadratic equation. What you might see is factors of 16 that can be added and subtracted to give us 8 are going to be 4 and 4. Both of them will be minus, and in this case we get k is equal to 4 or 4. No need to write that out twice. Double check that it doesn't cause our denominators to be 0, and we have the solution of our equation. Okay, moving on for the next one. Same idea. I need to start by factoring this trinomial denominator in order to be able to identify the LCD, lowest common denominator. So to get the p squared, p times p, factors of 10 which can be added and subtracted to give me 3. That's going to be 5 and 2. In this case I need it to be plus 5 and minus 2 in order to get my plus 3p in the middle. Lowest common denominator is going to be p minus 2 multiplied by p plus 5, and I'm going to multiply each of the terms in my equation by the lowest common denominator. And so after multiplying I should get 6p minus 12 is equal to, in this case the p plus 5 will cancel and I will be left with p, which is the term on top, multiplied by p minus 2, plus, once again, p plus 5 will cancel with this p plus 5, and in this case I'm left with p minus 2 multiplied by this one, which stays exactly the same. Much like example 3, I need to do some rearranging, move everything to the right hand side. So let's just switch up some colors here. So I'm going to subtract 6p and I'm going to add 12, and at the same time I'm going to do some distribution over there. So on the left hand side I've got 0, p squared minus 2p plus p minus 2 minus 6p plus 12. Clean that up. P squared minus 2p plus p is minus 1p, minus another 6 will leave me with minus 7. Minus 2 plus 12 will leave me with plus 10. Now I need to go ahead and factor. So factors of p squared, p and p, factors of 10 that will add and subtract to give me 7 must be 5 and 2, and in this case both of them negative, leading to answers of p equals 2 or 5. And as before, final step of the equation is to determine if either of those are extraneous, and in this case what you should see is if I were to take 2 and substitute it back into the original equation, it would cause a 0 denominator, and so I need to leave p represented as an answer but cross it out because it is extraneous. It's one of the excluded values. Okay, so now we're going to move on to the final section of the lesson, and that is to use what we know about solving rational equations, equations with fractions, in order to solve work problems or word problems that involve work rates. Okay, and so there's some key principles over here. If I know, if it takes me 3 hours to complete my homework, then I am completing 1/3 of my homework per hour. And if I am working with somebody else who is contributing to my homework completion, let's say a tutor, hopefully that's not what you're doing, but let's say you are, then if we're working together, whatever portion they complete plus the portion I complete will give us a whole, and you'll see these key principles used in the examples below. So I'm not going to try to explain those any more than that. We'll just go straight into the examples. Okay, so we have our first word problem here. Catherine takes 11 hours to clean an attic. So let's just express that as a rate. That means she will clean 1/11 of the attic per hour. So she's completing 1/11 of the total job. Our total job here is to have the attic cleaned. Jennifer can clean the same attic in 14 hours. So Jennifer is completing 1/14 of the job per hour. And the question is saying if they worked together, how long would it take them? And so the unknown, the variable in this case, is x, and x represents the number of hours that they're going to work together. Since they're working together, they are both working for x hours. And so Catherine will complete X 11ths of the job. So, for instance, if she had worked for 5 hours, she'd complete 5/11ths of the job. In this case, we have now got Jennifer. Jennifer is working for the same amount of time, that's why I'm reusing X, and she is completing X 14ths of the job, and together those sum to 1 because they are completing one job. They are cleaning the attic. Okay, and so what you see in this case is we have once again got ourselves a rational equation, an equation with ratios or fractions. What we need to do is get rid of those fractions. That's the easiest way for us to be able to solve the equation. So I'm going to start off by finding my lowest common denominator. So I want the number into which all of my denominators can divide. In this case, my lowest common denominator actually just ends up being 11 times 14, okay, which is going to give us 154. I'm going to take 154 and multiply each of the terms in the equation by 154. And what I'll get is 14x plus 11x is equal to 154. 25x is equal to 154. And therefore my final answer, x is equal to 154 over 25, which you can work out as a decimal value, around about a little more than 6. We could write that as a mixed number, in this case 6 and 4/25, or you could just leave it as an improper fraction, or type it into your calculator and write a decimal. So working together, they take a little more than 6 hours. Okay, final example. This is the same idea as the previous example, but the difference in this case is that in this case, the rate at which they're working is unknown. So what you'll see here is we had the time that they work together on top, and then we had the rate that they work at in the denominator. In example number 1, our unknown was the amount of time they work together. You'll see in example number 2, the time that they work together is given, and Mark's rate is given, and what is unknown is Jacob's rate. And so the setup of the problem is the same principle, but we have to set it up slightly differently. In this case, our unknown is going to be in the denominator. Okay, so let's just look at this. First of all, Mark takes 8 hours to complete the task alone. That means he is completing 1/8 of the job per hour. 5 hours is the amount of time that they work together, and so you'll notice in the first example the amount of time they work together went in the numerator. That was x because it was our unknown. In this case, the amount of time that they work together goes in the numerator because it's known. If Mark takes 8 hours on his own, then he completes 1/8 of the job per hour, and so this fraction over here represents how much of the job Mark is going to complete. 5/8 of the job because he completes 1/8 per hour and works for 5 hours. What is unknown is how long Jacob's going to take, and so Jacob's rate in this case is x. So imagine that was 10, Jacob would be completing 1/10 of the job per hour. In this case, Jacob is completing 1/x of the job per hour and is working for 5 hours, which is why we've put 5 in the numerator. Together, they will complete one task. And so the setup is very similar. This time my unknown is in the denominator, but the process for solving will be the same. I will find the lowest common denominator of all 3 of my terms. In this case, it's 8x. I'm going to distribute 8x to each of the terms. In the first term over here, when I distribute the 8x, the 8's will cancel, and I'll be left with 5x. In the second term, the x's will cancel, and I'll be left with 5 times 8. And on the right-hand side, nothing will cancel, and I'll be left with 8x. this is just a linear equation, which I'm going to do some rearranging. So 5 times 8 is 40. I'm going to subtract 5x from both sides, and I'm left with 8x minus 5x is 3x, equals 40. Final step, divide through by 3, and x is equal to 40 over 3, which is 13 1/3. So it takes Jacob 13 1/3 hours to complete the job if he is working on his own. Okay.